All right, grade 6. Now this is actually not a lesson in your textbooks because this is a review lesson for you. We are going to be moving on to operations. Our big idea is understanding operations helps us to solve problems in the real world, and we're going to connect that with decimals eventually. At this point, we're going to just review because often students forget all of their necessary steps for multiplication and division. So we are going to do some quick review of multiplication. We're going to demonstrate an understanding of multiplying two-digit numbers, two-digit whole numbers. A whole number means there is no decimal. Reminder, you may not use a calculator for this entire operations unit, all of chapter 3. No calculator is allowed. However, if you are struggling with your basic facts, you can definitely use a multiplication table. Just need to make sure you indicate that that was some of the support that you needed. So again, this is not from the textbook. You may want to take notes if you've forgotten. All right, we're going to start by reviewing 3 multiplication methods that we talked about in grade 5, or at least if you were in my class in grade 5. We learned the partial product method, which is really like the grid method. And I'll just show you the similarities here. So our question was 32 times 56. So with grid method, we would break it into its parts, 32 times 56. And it doesn't really matter if you put the 56 over here or the 56 over here or the 30 and the 2 down here. It really doesn't make a big difference, but I've chosen to draw it like this. Here you take the 30 times the 50 in this box. 30 and 50 meet up in that box. You can see we've done that with partial product as well. 30 times 50, we've taken the two tens and multiplied them, giving us 1,500. And this is where we can remember annexing 0, right? 30 times 50, we forget about the zeros for a minute. We took both of them off. 3 times 5 is 15. Well, we took off 2 zeros, so we have to put 2 zeros back on, 1,500. All right, now we look at the 50 times 2. So 5 times 2 again is 10. We took off 1 zero. We add that other 0 back on, which makes it 100. And again, we can see that step right here. Then we're going to go 30 times 6 to fill this box, which again, 3 times 6 is 18. We took off 1 zero. We have to put that 0 back on, 180. And you can see that right here. And 6 times 2 in this box, that's where they meet. 6 times 2 is 12, and then you would add them up. Again, you can see 6 times 2 is 12 here, and add them all up. Now, really very similar processes. I do find students tend to be more successful with the grid method just because they realize each box needs to be filled. Often when we're using the partial product method, one or both of these will be missed, and that can be a problem. So do try both methods and see if that grid does in fact assist you. If you don't need it and you don't forget all 4 steps, perfectly fine. Choose whichever process you find more effective for yourself. All right, now we're going to look at our traditional algorithm method. This was the way that I was taught when I was in school. It works quite well, but it has a number of steps, and students sometimes forget them. So again, give this one a try and see what works for you. So we need to start at the ones place. Okay, ones place, 2 times 6 is 12, so I put the 2, I carry the 1 to the tens place. Now I look at 3 times 6, which is 18, plus that 1 I carried, which is 19, so I write the 19 right here. I've finished now with the digit in the ones place. The 6 is complete. I don't need to do anything more with it. I also, as you can see, need to get rid of that borrowing so I don't include that again, because I might not need to carry again. Or sorry, that carrying, not borrowing. Now we go on to the tens place, which means I need to put a placeholder in the ones place. I usually put an X. Sometimes people put a 0. Some people put a happy face. It really doesn't matter what. but you do need a placeholder there. Sometimes if there's a 0 as the next digit as there is here, a 0 here can be confusing because you think, oh, yep, I've already done it, when in fact you actually haven't. So that's why I personally choose an X, but you can choose whatever symbol you want there as a placeholder. Okay, so we need our placeholder. Now we're going on to the tens. We have to go the tens times the ones. So 5 times 2, which is 10, hence my 0. Now I need my second one up there for my carrying. Now I look at the 5 times the 3. 5 times 3 is 15, plus that one that I had carried is 16, so I write in my 16 here. Now I need to add. 2 plus nothing is 2, 9 plus nothing is 9, 1 plus 6 is 7, 1 plus 1 is 1. As you can see, you end up with the exact same answer as you did for a grid method or a partial product method. So whichever method you find most effective for yourself, feel free to use that one. The last one is lattice method, and it's just kind of cool. Works really well with bigger numbers, I've found. So again, 32 times 56 are our numbers. So 32 at the top, 56 on the side. You need to draw a grid. So for the number of digits that you have, you need columns. So 2 needs a column, 3 needs a column, 5 needs a row, 6 needs a row. And then they need to be divided diagonally from top to bottom, from right to left. And it is important, has to be top to bottom and right to left. Now within each box again, we are multiplying those two. So for example here, 2 times 5 is 10. The 1 goes in the top diagonal or triangle, and the 0 goes in the bottom triangle. Over here it's going to be 5 times 3, which is 15. 1 goes in the top triangle, 5 goes in the bottom triangle. Here it's 2 times 6. 1 goes in the top triangle, 2 goes in the bottom triangle of 12. In this box it's 3 times 6, which is 18. 1 goes in the top triangle, 8 goes in the bottom triangle. And now we add each diagonal section. Okay, so 2, well, nothing adds with 2, so it's just 2. Here we have 8 plus 1 is 9, plus 0 makes that 9. Here we have 1 plus 5 plus 1, which is 7, and we're left with just 1. So this then makes that final answer. Remember not to just leave those digits around the edge here. You have to write them as a final answer. Otherwise, it's very difficult for someone who's looking at this to determine what the final answer is. So again, make sure to then write the final answer just to be clear. All right, now we have some to practice, and we're going to try 2 for each strategy. We're going to start the first one with grid or partial product method. I'm going to use a grid because I find that more works better for me. So we've got 20 and 4 and 10 and 7. We need a column for each, column for 4, a column for 20. Sorry. We need a row for 10 and a row for 7. All right, so here, 4 times 10. Well, I know that 4 times 1 is 4. Add my 0 back on is going to make that 40. 20 times 10 here, well, sorry, you should be pressing pause and trying these first. If you haven't already done so, press pause and try both A's in grid method, and we'll compare them in a minute, and then we'll go on to the both B's and the both C's. So go ahead and press pause right now. Sorry, I've got that one started for you already, but give it a go. All right, now hopefully you've finished those first two with grid method. We can continue with our checking of those. As I had just said before I realized that I hadn't given you a chance to start, 20 times 10, 2 times 1 is 2. We took off 2 zeros, so we have to add those 2 zeros back on, 200. In this box, it's going to be 4 times 7. 4 times 7 is 28. And in this box, it's 20 times 7. Well, 2 times 7 is 14. I took off 1 0, so I'm adding that 0 back on. And now, of course, I need to add all of those up. So 200, 140, 40, and 28. I would add those up. 8. 4 plus 4 is 8, plus 2 is 10, carry the 1, 2 plus 1 is 3, plus 1 is 4, 408. All right, let's try our second one with grid method. So we have 90 and 8, and over here we have 30 and 4. So 8 times 30, well 8 times 3 is 24. I took off that 1 0, I annexed it, now I'm adding it back on, 240. Here in this box it's 90 times 30, 9 times 3, 27. We took off 2 zeros, so we have to add those 2 zeros back on when we're annexing 0. And in this box, it would be 8 times 4, which is just 32. And in this box, 90 times 4. Well, 9 times 4 is 36. I took off or annexed 1 0. I'm going to add it back on. Now I need to add all of those numbers. 2,700, 240, 360, and 32, and I would add those up. 2, 6 and 4 is 10, plus 3 makes it 13, carry the 1. 7 and 3 are 10, and 1 and 2 is 3. 10 plus 3 is 13, again carry the 1, and 2 plus 1 is 3. So 3,332. And this is again where estimation comes in as handy. 90, which is close to 100, 30, which is close, 34, which is close to 30, 100 times 30, well, would give us 3,000. So yes, in fact, my answer is close. I'm probably on the right track. So don't forget to use your estimation strategies to see if you are doing them correctly. All right, now we're going to try the next two, and the next two we're going to try with algorithm method. So try both B's using algorithm method. Press pause and try that now. All right, so 36 times 18, algorithm method. Starting at the ones place, 6 times 8 is 48. So I put my 8, I carry my 4. 3 times 8 plus 4, well 8 times 3 is 24, plus 4 makes that 28. Put in my placeholder, get rid of what I borrowed so I don't use that number again. Now I'm looking at the tens place. 1 times 6 is 6. Remember to put in that placeholder, of course. I chose a 0 this time. Usually I make it an X. Let's make it an X again. So I've done my 1 times 6, that's 6. Now I have to do my 1 times 3, which is just 3. Now I just need to add those. 8 plus nothing is 8. 8 plus 6 is 14. Carry the 1. 1 plus 2 is 3. 3 plus 3 is 6. So 648. And again, I can use estimating to check this. 36 is pretty close to 40. 18 is pretty close to 20. 4 times 2 is 8. We took off 2 zeros. We'd add them back up. 800. 648 was somewhat close to 800, so that one's not bad. Could be, probably is right. So using that estimation to help you check. Let's try the next one, algorithm method. 70 times 25. And again, I start with my ones column. 5 times 0. Well, always something times 0 is 0. So 0 it is. 5 times 7 is 35. So I put down my 35. Now I'm going to my tens place. So I need to have my placeholder. And now I'm going tens to ones, 2 to 0. 2 times 0, well again, anything times 0 is just 0. And now 7 times 2 is 14. I have to add those up. 0 plus 0 is 0, 5 plus 0 is 5, 3 plus 4 is 7, and 1,750. And again, I can estimate to check. Well, 70 is fine. 25 could become 20. Annex those zeros. 7 times 2 is 140. I took off 2 zeros. I'm going to add 2 zeros. Yeah, that's not too bad. That's fairly close. I could even have gone made this 30, at which point this would be 2,100, which is also fairly close. Remember, when multiplying and dividing, your estimates aren't going to be quite as near as they are when you're adding and subtracting. All right, now we're going to press pause and try lattice method for both of the C's. Try lattice method for both of the C's. Press pause and do that now. All right, so let's give it a go. So 51, and I need a column for each of those, and 19, and I need a column for each of those, or row, I guess. Notice these do not here become the 50 and the 10. They stay the 5 and the 1. So that's the difference that you need to not mix up when you're using this method and grid method, because they are somewhat similar. So just watch for that part of it. And then, of course, we need to divide them diagonally, and it has to be from top to bottom, and it has to be from right to left. So watch that. All right, now let's check 1 times 1 in this box. Well, 1 times 1 is 1, so I would put a 0 in this box and a 1 there. In this box, it's 5 times 1, which is just 5, so 0 in the top part and 5 on the bottom. Now, in this case, 1 times 9. 1 times 9 is just 9. 0 and 9. The trickier one, 5 times 9 is 45. 4 on the top, 5 on the bottom. Now we add each diagonal section. So 9, 5 plus 1 is 6, 4 plus 5 is 9, and 0. Now it's very hard for someone to realize that that's the answer, so we do have to write the answer separately. We don't need that 0 at the front. We can just get rid of it, so it's just 969. And again, we can use estimating to check if we're on the right track. 50 times 25 times 2 is 10. Add that extra 2 zeros that we took off, which is 1,000, and 1,000 is close, very close actually, in fact, to 969. So in this case, our estimate was quite close. Right, now let's try our last one. 23, we need a column for each of those. 61, we need a row for each of those. Dividing our diagonals top to bottom, right to left. And in our first box, we have 3 times 16. 3 times 16 is 18. 1 on the top, 1 on the bottom. Our next box here, and it does not matter what order you do them in at all. It's entirely up to you. 2 times 6 is 12, 1 and 2. And here we have 3 times 1, which is just 3, 0 and 3. 2 times 1, which is just 2, 0 and 2. Adding each diagonal section, we end up with 3. 2 plus 8 is 10. Now, this is where it gets a little tricky. We have to put a 0 there, and we actually carry over here, but this doesn't become 11, it becomes 1 plus 1. So 1 plus 1 plus 2 is actually 4, and then 1, and again we need to rewrite that because that's going to be confusing. People aren't going to know that they need to look at these particular digits or if they need to look at these other digits. So 1,403. And again, let's estimate to check. Well, 20 times 60, 2 times 6 is 12. We took off 2 zeros, we add those 2 zeros on, 1,200, fairly close to 1,403, probably correct. I've had an opportunity to try all of them. Now, remember, it doesn't actually matter which strategy you choose. I just want you to try each and every one of them so you have had experience with all of them. And now that you've experienced all of them, you decide which one you would like to use. It does not matter which choice you make. You work with the one that you find easiest for yourself. Okay, and concept practice today, because this is not in your textbook. It is from other pages that I have made up. or collected. So we're multiplying 2-digit numbers, and your concept practice is on the screen today. Do make sure to show your work. You may not use a calculator. If there is no work, I'm going to assume you've used a calculator, and you will have to do them over again. On a separate page, so all work is visible and not squished. Actually, you're not getting the page this time, so it doesn't matter. It'll have to be on a separate page, so that works out. You need to complete these questions using whichever strategy you prefer, as well as this problem-solving question. You make sure again that you are showing all of your work. So go ahead and press pause now and do these questions on a separate page to demonstrate your understanding of multiplication process before we start to add decimal numbers into the situation.